Good morning everyone. My name is Dr. Raja from Tirthanga Nadar College. I am working in chemistry department. Today teach about physics 1. The title is ultrasonic. What is the difference between the waves? So actually one different type of the waves irukku. Particularly teach about the ultrasonics. Ultrasonic ranges means the range of heats. The range of heats means the waves range of heats. It will be called as below 20 heats. Is infrared. The only hearing the voice hearing the sound will be animals. Second, above the 20 watts, 20 hertz to 20 kilohertz is a immunity hearing voice. Above 20,000 watt hertz, 20,000 kilohertz also called the ultrasonic wave. So only study about the ultrasonic wave. What are the purpose of using the properties? What are method of using the production of ultrasonic wave? So the contents also include to the definition of ultrasonic. What is the ultrasonic? The ultra means the new pattern. The sonic means is the presence of the sound. We apply to the some energy also called the mechanical energy. The mechanical energy will be converted to electrical energy. The mechanical is called the energy. The energy is a form of a sound. That the energy is form of sound. That sound will be converted to that electricity, some other the wave pattern. So second is the properties of ultrasonic. The wave will be propagated to the straight line depend upon the property or include to the wave depend upon the ranges of pattern. So ultrasonic the production. What is the method of production of ultrasonic? The method will be production of piezoelectric method. The piezoelectric method we utilize through the different range of ultrasonic pattern. So second is a magnetoseriction effect. The another part of the production of ultrasonic waves is a magnetoseriction effect. Last one, the application of ultrasonic wave. So first one is the definition of ultrasonic wave. The ultra means the beyond. The ultra means the beyond. The sound sonics means the sound. So it will be produce the sound before you get the after get the using many more application in electricity. The sound waves in which the frequencies are the above the limits of human audibility is a less than of 20 kilohertz. Okay, 20 kilohertz is the immunity of audible rays. So it's called the ultrasonic waves. The ranges of ultrasonic waves and the description of ultrasonic with example. So frequency, description and example. The less than of its less than of 20 hertz is called as a infrared and is a acute and it is audible for some animals. So above 20 to 20 kilohertz is a audible sound. For example, the music are peaceful, pleasant in a sound. That is a music. So above 20,000 kilohertz is called the ultrasonic waves is a black. The properties of ultrasonic wave, the wave will be propagation through the energy will be content, will be the light ray will be passing through the single ray or single or monochrome ray. The velocity, in particular the speed of velocity depend upon the light wave will be the depend upon the light wave temperature and the frequency of medium. So velocity, the light speed of velocity is passing through the one place to another or one place to or medium of the path will be focusing or passing through the medium. Medium means there are presence of the reflection and refraction. First ray is a incident, second ray will be depend upon the medium of or beyond the medium of refraction, another medium of refraction. That is a depend upon the incident angle of the refractive angle. That is a form of calculate the velocity of ultrasonic. Just like the ordinary waves, ultrasonic is the reflector and refractor and the observer. So normal the light wave property will be included to the ultrasonic properties. So ultrasonic production, the ultrasonic waves will be production of two type of method. One is a follow the piezoelectric generator. The second one is a magnetoseriction generator. The piezoelectric method will follow the mechanical pressure. If you follow the mechanical pressure, apply to the opposite phases of crystal. The mechanical pressure apply to the opposite phases of crystal. The equal and opposite electric charges appear across the phases. So he apply to the energy, opposite pressure means he say beyond. Beyond means before he apply to the mechanical energies. Particularly, he is a wave particle. He applies the sound wave or charges, the frequency ranges of the charges. Will be calculate the energy levels. Energy level means the depend upon the energies, including the potential difference. The developed would be the proportional to the pressure applied. The potential energy he applied to the depend upon the mechanical energy. Depend upon the mechanical, he applied to the some kinetic energy, he applied to the potential energy involved to the mechanical energy. The type of energies involving through the difference of the energies or differences of the frequencies, difference of the frequencies. He calculated the difference, the potential difference. That would be the proportion to the pressure applied. Means the mechanical pressure. He applied to the mechanical pressure depend upon the opposite phases. The converse, the piezoelectric effect also true. It will be applied the pressure will be form of the finally get the piezoelectric method. It will be produce the ultrasonic wave pattern. The effective just observe the quartz. The material will be utilized through the ultrasonic material, quartz crystal and tourmaline crystal. There are the using in the piezoelectric method will be converted to ultrasonic. So the experimental method, the principle working. So the mechanical pressure will be applied to the opposite phases. It will be applied to the opposite phases. So it will be consumed to the drum or a disc. Applied to the pressure. Clearly applied to the pressure, opposite pressure. Will be get the frequency. You get the frequency or potential difference, which would be proportional to the pressure applied. How will measure, how will different between from the at the disc of the level, monitoring the voltmeter. Monitoring the voltmeter, the form of the principle. The experimental method, the piezoelectric generator, will be called as a AB, the crystal. The quartz crystal placed in the between A and B plate. It will be first is a primary cell, is a secondary cell. The primary cell will follow the coils L1 and L2. Will be conducted through the L3 is a transformer coil. Will be inbuilt of the transformer connected to the battery. Will be a transformer, one point will be connected to the primary coil L2, another frame connected to the L1. Will be parallel. The parallel plate capacitor will be connected to the primary circuit. The primary circuit and secondary circuit will be involved to the transformer. First, the plate will be connected to the primary. The coils, the collector will be coil inductively coupled with the base of the coil. So, a light ray means he applied to the some mechanical pressure inside of the AB plate. Will be produce the electricity. He produce the some wave pattern. That way we will calculate the range of frequency at a level of 20 to about 20 kHz ranges. The working of generator. So the working of the battery is switched on. It's a battery switched on. The produce the high frequency of alternating EMF. High frequency alternating EMF or alternating voltage with the frequency. Therefore F equal to 1 by 2 pi root of L1 into C1. So L1 is the presence of the primary coil and will be parallel will be connected to the capacitor in a C1. So it will be presence of the highly frequency alternating in the voltage. Will be collecting the ranges or will be segregated through the ranges due to the transformer action. The oscillator, the EMF, the electromagnetic field is induced in the coil L2. Induced in the coil L3 means the secondary part of the coil is induced in the coil L3. The high frequency alternating voltage are the effect on the plate of A and B. So it will be connected to will be converted to the range of differential will be L3 coil. Also L3 is a frame, secondary coil will be induced the EMF. The electromagnetic force will be induced. The range of frequency will be converted to the A and B plate. They will be produced the quartz crystal or tourmaline crystal. It produce the ultrasonic wave pattern. The range of frequency also called the highly range of frequency. The third point, the physiological effect is placed at the crystal, counted on the expand of the alternatively the frequency of the vibration of the given wave. So actually the frequency, next modulation of the wave frequency is also vibrating. Therefore n equal to 1 by 2 or 1 by or p by 2 L into root of y by p. So p is the density of the crystal. What will be used in the crystal, like quartz or tourmaline crystal, that finding the density of the crystal. Second, Y is a Young's modulus. Y is a Young's modulus. Therefore, P is the frequency or utilized through the length between the slope of the, means the A and B, the slope of the quartz crystal length of the crystal. Okay, you will find in the vibration of the frequency through the piezoelectric method. So the second last one is the variable condenser. Variable condenser means utilized in a capacitor C1. Adjusters such as the frequency that applied the voltage is a equal natural frequency of the resonance of the places. So equal means you'll be made up of adjusting the batteries, will be adjusting the capacitor or condenser. Capacitor condenser will be produce the range of ultrasonic wave in a X-ray method. The second part of the magnetic method, that method also same method will be placed in the ferromagnetic method. That material is a ferromagnetic material rod like iron or nickel placed in the magnetic field parallel with the length of the rod. So same method will be utilizing in a ferromagnetic material will be placed in the parallel plate capacitor. Okay, it's a length and is called the magnetization effect of the. Will be magnetic means in the ferromagnetic material length will be concerned. Length will be concerned. You apply to some pressure, apply to some energies. You will produce the frequencies or vibration of the frequency. You will be increasing the length of the material, means the rod or material. The produce the many more frequency, many more wave pattern in the instrumentation of the magnetic resonance. The change in the length of produce the rod. Next, the depends upon the strength of the magnetic field. Means in the strength of the rod, will be changing the length of the rod, will be produce the many more range of frequency in here. That method also called the magnetic resonance. That method will be experimental method. The XY, is the rod of ferromagnetic material like iron or nickel. So L1, L2 is the primary coil will be connected to the transistor. Transistor will be again parallel connected to the condenser or capacitor, will be connected to the milliammeter, will be follow through the batteries. Will be form the XO plane. The XO plane means is a primary coil or secondary coil will produce the ultrasonic wave pattern. Okay, the coil L1 would be like the rod along the variable capacitor C. The frequency of oscillator controlled by the variable of the capacitor. The frequency means the condenser will be variable or capacitor will be variable. You will produce the many more range of ultrasonic waves. So working of the generator, the part of the magnetoseric experiment will be the experiment the working of the generator. When the battery is switched on, the collector circuit will be oscillating the frequency. The collector circuit will be oscillating the actually a transistor also follow up the three part. One is a common emitter, second one is a common collector, third one is a common emitter. The follow of the common collector. The common collector circuit will be oscillating the frequency. The F equal to 1 by 2 pi the root of L1 into C. The L1 means is a primary coil will produce the ultrasonic wave. C means the variable capacitor or variable condenser will be connected in a parallel. The current following through the coil L1 produces the alternating magnetic field. Is a ferromagnetic material also produce the magnetic field alternatively in the length of the rod. So length of the rod means the length of the rod means X and Y. So they place it in a bottom of the plane will produce the range of ultrasonic wave. Depending upon the length of rod will be produce many more range of frequency in a method. The frequency of vibration, second is the part of the vibration method. Therefore n equal to 1 by 2 is the root of y by p. So E is also Young's modulus. And the material of the bending moment or rho is the density of the material. What will be material will be used in nickel or some other material will be using in a ferromagnetic material to find the density of the material. The capacitor is adjusted to the frequency of the oscillator is equal to the natural frequency rod and this the resonance of the depth of this. The capacitor is a variable capacitor will be connected in a circuit. You will adjusting some level of 0.5 microfarad or 0.8 microfarad level will be increasing. Adjusting will be produce the many more range of vibration in a frequency. Now the rod will be vibrate longitudinally. Rod will be vibrate longitudinally with the maximum amplitude generate the ultrasonic waves, frequency or say efficiency of waves. The finally get the application of piezoelectric method and the magnetization effect. It's a detection of fillers in the metals. Detection of fillers in metal means how many length of the rod will be using in a material. You get the range of frequency or range of frequency in a vibration frequency of wave pattern. Second is the sonar. Sonar means the sound navigation and the range. The sound navigation means it will be protecting the ultrasonic wave. So it will be alarm or some other depthing or some other level to finding or monitoring. That is using in a sonar the experiment. Second, the ultrasonic welding is minutely you welding some material or welding the minutely you apply to the some wave pattern using the ultrasonic welding. The ultrasonic cutting and machining, particular range of waves or range of frequencies, range of vibration depend upon used in some medical field or scientific field, some agriculture field, some industrial field, using in a cutting some machines, diamond cutter to diamond, but in the range of ultrasonic used in a material also cutting in a machinery. The ultrasonic soldering. Finally, the easily the semiconductor chip based material will be soldering through the ultrasonic wave part. So the second part is here viscosity. Second part is to study about the density of different density of the liquid or fluid material. Today see about the viscosity. The viscosity is the quantity measure of the fluid, resistance of fluid. Quantity measure of the fluid. Fluid means the liquid based on the traveling one place to another place or a zigzag or turbulent depend upon the density of the liquid. Clear? Depend upon the density of the liquid. One is a dynamic viscosity. Second one is a kinematic viscosity. Dynamic viscosity will be finding the neta equal to, neta means the coefficient of viscosity of the liquid. The force divided by area into nu by h. Okay. So the neta means the force directly proposed to the coefficient of viscosity or force directly proposed to the area, the force directly proposed to the velocity gradient. The liquid will be flowing through the one point to another point or considered to cylindrical. The flow of the pressure, inside pressure or outside pressure. So therefore nu equal to or neta equal to nu by h or Newton seconds per meter square, the unit of coefficient of viscosity. Second, the kinematic viscosity, therefore nu equal to n by rho. Nu equal to n by rho, the meter square by seconds. The rho means density of the fluid. What will be liquid following through the density of the liquid? Water also calls water or kerosene, some other petrol. The liquid will be following through the densities. So second one is measuring the viscosity. In means to finding the capillary viscometer will be calculating through the liquid level. At the bottom of level, the saturation fluid through the stop mask. We will be sucking the tube, will be increasing the level of liquid. In the level of liquid, will be one by apply to the some pressure. Apply to the pressure or sucking through the bottom of the liquid will be increasing the top of the level. You will finding the different pressure level within the different pressure level between the end of the tubes. You are monitoring the viscosity V equal to pi R44 GLP divided by 8 LV. Therefore, K into T2 minus T1. The T2 means the measuring in the range of time flow through the pressure different upon. Next, the rotational viscometer is a follow of the rotational viscometer. Sucking the liquid level will be increasing the low level to high level. Molecule will be rotating through the variable pressure rate. That is finding the rotational viscosity. The rotating cylindrical viscometer. The cylinder viscometer is inside of the cylinder or outside of the inner wall. Will be applied to the pressure. Will be rotating the molecule. That finding the pressure will be followed the coefficient viscosity. Therefore, neta equal to driving motor or some other using instrumental method, flow through or sucking through or a human method that is followed. So cone again. Second first is here cone and plate the viscometer. Cone and plate means will be rotating. The rotating the tube will be follow up the cone stage. Will be again sucking or pumping or pumping to the liquid level. Will be increasing to the lower level depending upon the time or period of the calculate through the initial time to final time. Okay, we will be monitoring the temperature at level of graph meter as a kinematic viscosity in the depending upon the time temperature. So only see depending upon the pressure with the viscosity level. This level of color will be added to the levels: mercury, water, the oil, air, and hydrogen of the helium. So the effect of the temperature will be follow the Reynolds. Is a scientist predicted by the equation number eta and the slot and water and worker. So we will be follow the different method, different science will be focusing through the different fluid or different liquid will follow the viscosity of temperature function. So overall the effect of the temperature involving to the pressure level, graph will be monitoring through the level of fluid. Fluid means in different liquids at the stages of the graph method. Say viscosity index. The viscosity index will be finding the L minus U divided by L minus H. The U viscosity index, the kinematic viscosity of the meter. The L is the kinematic viscosity of the reference oil. You take about some castor oil or crystalline or kerosene or some other water. You say the viscosity to find the viscosity index. So effect of the pressure. The depend upon the fluid will be traveling one place to another place. Will be monitoring the pressure level. Therefore, NP, the viscosity of the pressure N naught into e power AP. So the follow the effect of the pressure level. The effect of the pressure will be follow the 0 to at a Pascal level 1 to 10 power 8. The pressure will be sensitivity of the in monitoring the Pascal of the unit. So application, the follow of the application in the viscosity, the selection of lubricant for various purpose. The selection of lubricants from the different, there are the different liquid fluid in a, using in a different function depend upon the industry. We can choose the optimum range of the viscosity for engine oil. So optimum frequency means will be spreading to the areas or will be travel to the one place to another. That form of the optimum range. The high load also fit of the operating high viscous lubricants also liquid. Depend upon the range of liquid will be follow the spreading in an area, so pumping in operation or other low viscous liquid, high viscous depend upon the instrumental or depend upon the industry also use less viscous fluid easily to the mix. The operation will be coating and printing. The liquid will be more than liquid level or fluid level will be coating or liquid will be finding. That's application also follow. So the conclusion about the topic. So we are discussing the ultrasonic. What about ultrasonic? What is mean by ultrasonic? What is the production of ultrasonic? What is the range of ultrasonic waves? The range means 20, above 20, below 20. What is the using in here or hearing the varying the sound of ultrasonic? The method will be follow the two method production of ultrasonic. One is a piezoelectric. One is the production of wave pattern. Second magnetostriction is finding the application. The next part is a viscosity. Viscosity means the fluid, study about the liquid or study of the fluid in a density. Different upon the different method. The liquid will be follow the different method. The different method will be using in a different application. That's all. Thank you.